Now, those of you who know me personally, or perhaps those of you who follow the channel on Facebook, probably can understand why I'd love the ability to teleport. See, I'm living in the Netherlands personally, but my family is across the ocean in the United States, all the way from New York to Montana. Meanwhile, I have friends all the way over in Australia. To be able to pop in and out of existence at will anywhere in the world, it'd be like a dream come true. But sometimes I consider more on the mechanics of teleportation, and it starts to scare me. Welcome back to Get Smart with Rory, and today we're going to be discussing why teleportation will probably kill you. Okay, so before we begin, it's important that we define what we mean by teleportation for today's video. We're not talking about using some portal gun, no Star Trek styles matter transporter. No, today we're going with the simple, fairly iconic teleportation where one moment you're here, the next you're there, maybe with a little clap, poof of smoke. Simple. I consider it to be the classic. And we're definitely not going to be going into any quantum superposition, existential dread of being a probability of all places at once. Way too complicated. So, now that that's settled, we get to the first problem. Really the problem that we're going to run into with any kind of superpower or other thing outside of the norm. The first time you try it, unless there's some kind of handbook that you get, you don't know all of the problems that are going to be associated. And for a lot of the problems, not correcting for and correcting for are going to be equally fatal. And even in the movies, first time sucks for everybody. So just keep this all in mind as we go to the rest of the video. So, moving on to the first teleportation specific problem. That is, when I teleport somewhere, there's already going to be some sort of matter where I'm teleporting. Now in the movies, we always worry that you're going to teleport into a sheet of rock or into a volcano, but really, in the real world, even teleporting into air is a massive issue. A teensy bit of air going into your bloodstream is cause for a cardiac arrest. And if I put a human-sized amount of air into a human, it's like an overinflated balloon. You are literally going to pop. And I hate to tell you, but popping is quite fatal. And that's actually still best case scenario. Because, you see, when I put a bunch of air atoms into a human, suddenly it's not just filling a pump. They're just appearing there. So you have a high chance that at least one of those nuclei of air is going to be very close to the nuclei of human. And when two nuclei get very close together, you get nuclear physics. That means explosions. Big explosions. And that's still not worst case scenario. Because when you have that many atoms just appearing next to that many other atoms, you don't just have the chance of two nuclei being close together. You have a chance of two nuclei being on top of each other. That's not just nuclear physics. That's quark nuclear physics. We can't replicate that even in the Large Hadron Collider. You're going to see physics that have never before been seen, probably with a huge energy release. So, for science sake, I hope that if this is how teleportation works, you're being studied by a physicist who's suitably far away, like the moon, maybe Jupiter, because it's going to be fantastic, and we don't know how fantastic that's going to be. Good luck with that. Okay, so we're going to say that unless you're teleporting into deep space, just appearing in the matter is no good for anybody. Next best case, well, worst case, what if when you teleport, you expand out, just push the matter out of the way? Rock is still probably an issue for you, but air's probably okay, right? Well, sort of. Air pressure is no laughing matter. When you push that much air out, it's going to create a burst, like popping a weather balloon. you're probably going to see your ears bleed, probably eyes bleed, get bruises all over your body, I would expect. Maybe shatter some windows, deafen people near you. Probably not fatal, at least not right away, but not comfortable. Use it as a last resort to get out of a bomb explosion, a bullet piercing your skin, something like that. But generally, I would still stay away from it. No, what you really are hoping is a system such as that the matter where you're teleporting to and your matter switch places volumetrically. So, you get a human-sized amount of air that is appearing back where you were. There's still probably going to be a little pop, maybe a little shimmer as temperature, pressures equilibrate. Might be mildly uncomfortable if you're teleporting, say, from Everest down to sea level, but decidedly not fatal, and overall reusable. You do have to be a little bit careful still. Now, you don't worry about teleporting to rock, at least not right away, because you just get a Rory statue in the mountain wherever you teleported. That's not bad. But if you teleport halfway into a person, or even just a little bit into a person, suddenly a part of them is going to be back where you teleported from, and losing a finger, that's bad. Losing a hand is a emergency room hospital. If you don't take care of that, fatal. Anything bigger than that, probably instantly fatal. Not to mention, probably extremely traumatic for you. So, I would say, take the advice of comics, teleport to places where you can see. At least, if you can help it. So, that takes us to the next problem, though. If you would ignore that advice, if you decide that you don't care about teleporting places you can see, you're going to have landing pads that no one's allowed in, private hotel rooms, you're safe from dangerous moving things that you teleport mixed parts with. But you do run into another problem. How you're oriented. See, when you teleport, does your body stay oriented, fixed to a neutral point in space? Or somehow know that you should stay oriented relative to gravity? If, me in Europe, I teleport to Australia, am I going to land on my head? For that matter, even if there's a slight incline difference, that's begging for a twisted angle. And we've already decided that we're probably switching places with matter. If half of my leg is caught in rock and I'm unbalanced, that's a broken shin. It's not fatal, probably, but it's dangerous. You have to be very precise and probably have great reflexes to catch yourself in whatever weird orientation that you find yourself relative to the Earth, even if your orientation stays centered with the gravity. And that's not even the worst, because when you're teleporting, we've covered that for that, you need some precision. But the Earth is spinning. And exactly how instant is your instant transmission? Is it truly instantaneous? Are you one place, one moment, and one quantum picosecond later in the next place? In that case, you're probably fine. But what if it's a literal blink of an eye? Eye blinks are about 1/10 of a second. So, in that time, near the equator, the Earth is going to move 46 meters. The Earth is moving 1,000 miles per hour, give or take, at the equator. And you're going to have to make that adjustment for every different latitude you go to. At the North Pole, there's no lateral movement. It's spinning a little bit, but the amount it spins in 1/10 of a second, minuscule, not worth worrying about. As you go down towards the equator, or up towards the equator if you're in the southern hemisphere, you have to figure that it's going to be moving. 46 meters is a lot. It's half of a football field. That's the next building over. That's into a boulder, into a street. You have to be really aware of where you're teleporting. And that's not even really the worst of the movement. See, yeah, the Earth is spinning. But what you don't take into account is that the Earth is actually also moving around the sun. So, to get around the sun, the Earth takes 365 days. It's a long time, sure, but to do it, it has to make a trek of 600 million miles. It has to be booking it to make it. That turns out to 18 miles every second. Using our example of 1/10 of a second to teleport, that means that you're going to be not 46 meters off target, but 1.8 miles off target. That's a big deal. Now you're not the next building over, you might be in the next city if you're close to city limits, or at least certainly in a different neighborhood, or, deep in the ground, high in the sky. A mile up is no laughing matter. Now, you can figure this out, that if it's dawn or dusk where you teleport, then you're going to be up or down, depending on which. Or if it's noon or midnight, you're going to move exactly laterally, east or west. So you can at least take this into account, but again, it's going to always change depending on the time of day in the place you're teleporting to. And once again, it's not simple. Technically, yes, the Earth is moving slightly faster in January because the Earth is closer to the sun. Kepler's law, look into it. Not going to this here. But it's always going to be a thing that you have to worry about. Honestly, teleporting into the sky might be your best bet. Safer than trying to figure out wherever buildings and people are going to be with that much of an error. Of course, then you need a parachute, but okay, so it's a fun parachuting adventure every time, assuming you can bring a parachute. I wouldn't say that teleporting naked places is as inconvenient as killing yourself, per se, but you do have to realize you're not sure that you can teleport with clothing. At least not first time. Hopefully you figure it out. Maybe you can, maybe you can't. But it is something to think about. So, okay, that's all well and good. Except, the Earth isn't just spinning. The Earth isn't even just moving around the sun. The sun is moving around the center of the Milky Way, and a lot faster than the Earth is moving around the sun. Turns out that the sun moving around the Milky Way galaxy is moving at 143 miles per second. Now, the good news is it's a 200 million light year journey. It's not going to do it any time that you need to worry about. It's always going to be a fixed vector. But you do need to do the arithmetic of how that vector interacts with how you're teleporting depending on time of year, depending on time of day, depending on latitude. These things are going to matter. And you'll have to do that arithmetic every time. Because 14 miles plus or minus 2 is a pretty big margin of error. And there's another, once again, fairly constant vector, that the galaxy is also moving through empty space. You can add this to the vector of the sun moving around the Milky Way. They're both, as far as we're concerned, fixed vectors. But it is another piece of geometry that if you don't consider this, you're in trouble. And if the power doesn't utilize one or other of these movements, if for some reason teleporting is going to calculate that the Earth is moving and the sun is moving and all of that, but it doesn't care that the galaxy is moving, somehow it stays fixed relative to the reference frame of the galaxy, then you're going to be 14 miles off. Actually, galaxy is moving an amazing 360 miles per second. It's fast. That's 1.3 million miles per hour. So if that piece is missing and the others are off, then you're off by 36 miles. Probably in a bad direction because you included it. And it turns out your powers didn't. It's bad. And even if you do all of the calculations correctly, you get that precision teleportation, or throw precision out the window, and you just say, okay, I'm going to teleport, I'm going to end up in the sky, skydive down, I'm lucky enough to be able to bring a parachute, no big deal. There's still one more really major issue. You have momentum, and the Earth has momentum, and that momentum needs to go somewhere. If you're not able to bleed it off somehow, then you have the issue that, once again, at the equator, the Earth is moving 1,000 miles per hour with you on it. You teleport to the other side of the world, again on the equator, your momentum says that you should still be going 1,000 miles per hour. But the Earth is now moving 1,000 miles per hour in the wrong direction. Now you have the issue, you're colliding into trees, buildings, skyscrapers, 2,000 miles per hour. Even if you go way up into the sky, 2,000 mile per hour winds? For a reference frame, Category 5 hurricanes during gusts are only around 1/10 of that speed. It's going to be bracing, assuming that you don't hit a bird or something. You'll survive it. We've actually done experiments in wind tunnels and seen funny videos of military people having their cheeks blow back from really extreme air speeds. But it's dangerous. It's uncomfortable. And that's still assuming that all of the rest of your math, all of the rest of the powers work out. So, unless you're living in a comic book world and things just magically work out in your favor, if you don't know exactly how your teleportation works, I wouldn't risk it. Take the bus, airplane, like the rest of us mortals. Or, roll the dice. Up to you. Am I missing something? Is there more that you'd like to hear about? I'd love to hear from you, and if you enjoyed the video, don't forget to like and subscribe, and click that notification bell so you never miss out. Till next time, see ya.